Okay, so welcome back. Let's just keep going with this example. We've defined all the different change in pressures with 2 question marks. So let's put this in our equation up here. Let's see what happens. So the change in pressure, delta P1. Delta P1. Well, that's question mark. So we'll just say delta P1 plus delta P2. Well, delta P2 is gamma F times Y1 plus Y2 plus Y3 plus H plus pressure change of path 3, which we define to be negative gamma M times H plus 4 here. 4 here would be negative gamma F Y sub 3, and then we'll just continue this equation down here. Oops, just change this paper right here. So that's the change in pressure of path 4. Now, change in pressure of path 5, well, that was negative gamma F Y sub 2, and then change in pressure of path 6, and we said that was a question mark too. So let's actually let's see what's going on at path 6. And remember, path 6 was this path right here. So we said our total energy head along a streamline, V squared over 2G plus pressure over gamma plus H is equal to a constant, right? Because the total energy head here and here should be the same. Now we know the velocity here, the velocity at this point and the velocity at this point, they're the same. So this is going to be equal to a constant, right? So this entire term is a constant. H, is there a change in elevation from this point to this point? Well, no, there isn't. So that's also a constant. And if this is a constant, if the equation equals a constant, and if this term is a constant, that means the pressure is also going to be a constant. Okay, so there's going to be constant pressure along this path. So we can actually just say that change in pressure along path 6 is just 0. So this is 0. Don't worry about it. There is no change in pressure, right? If this pressure was like, I don't know, 5 psi, and this was 5 psi, they're both constant, they're both the same. 5 minus 5 is 0. Plus the change in pressure of path 7, which is negative gamma F Y sub 1. And here's where we start canceling things out. So let's cancel a few terms. We know, well, look at this, negative gamma F, that cancels out with this one, right? So this is gone. And then we have gamma sub F of Y sub 3, that's gone. We have a negative gamma sub F of Y2, that's gone. I believe that's it. So that's gone, this is gone. So we're left with the change in pressure is equal to the change in pressure of 1 plus gamma F H, right? Gamma F H minus gamma M H. Oh, well, I think that's it, isn't it? So here, and remember this is equal to 0, right? The total change in pressure of the entire path is equal to 0. So we can rewrite this as a change in pressure of 1 plus H times gamma F minus gamma M is equal to 0, right? I just distributed that h out. We can bring this over to the other side. We say change in pressure is equal to H times gamma mercury minus gamma F. Alright, we just brought that over and did some algebra work there. Now, to find out the change in pressure of path 1, remember path 1 is this path right here. Here, we said the change in pressure was 0. Well, can we say that the same about here? Well, no we can't, because there's a velocity here, and there's no velocity here because that's a stagnation point. That's 0. So there is a change in pressure there, but there isn't here because the velocity here and here are the same. The pressure here and here is the same. And the height is obviously the same. Here, the only thing that's different between path 1 and path 6 is that there's a velocity change, okay? So we can use Bernoulli's equation. Remember, the total energy head along a streamline is the same, so energy head here would be equal to energy head here. And remember, our energy head equation was V squared over 2G plus pressure of 0, right? We're doing this for point 0. So we can even say that. Over gamma plus H is equal to V. We'll call that point S. That's stagnation point here, right? That's stagnation point squared over 2 times gravity plus the pressure at the stagnation point over gamma plus H. Okay, well, can we say this is equal to 0? Why? Because the velocity at the stagnation point is 0, right? And the heights, they're obviously the same. There's no change in height. So what we're left with is V naught squared, or V0 squared over 2G plus the pressure at 0 over gamma is equal to the pressure stagnation point gamma plus H. Oops, no plus H. If we bring this term over here, we can say V naught squared over 2G is equal to P of S minus P naught over gamma. Gamma of the, remember, the fluid, the air. Right? I just subtracted this term from this side and brought it over here. And this is what we get. So we have this. And this right here is actually the change in pressure along path 1. Right? Stagnation minus 0.0. Or final minus initial. And that's equal to rho g times v squared over 2g. And this right here, remember, it's our gamma. Gamma is equal to rho g. And all of this is equal to rho of the fluid, v squared over 2. And remember, we define this as gamma f over 2g. So we can plug that in here and say gamma f times v squared over 2g is equal to gamma m minus gamma f h, right? The change in the two gammas times h is equal to our change in pressure, because our change in pressure is equal to gamma times the change in height. Okay? And that's that right there. Let's solve for v squared here. We get 2g gamma mercury minus gamma f times height over gamma f. And we square root both sides. We get v is equal to 2g times gamma mercury over gamma f minus 1 times h, and all of that square rooted. Okay? So that right there is the velocity it's the velocity of this air. It's the velocity of point 0.